Okay, let's start this amazing project. So let's click on New Project. And I'm going to choose 2D URP as my template. And you can choose your location. I'm just going to keep it to the default here, which is in a folder called Morgan Page Courses. And I am going to call this Maze, and then click Create Project. Okay, once that project is open, I am going to change my layout to Morgan, which is essentially 2x3 with a console down here. And then in Assets, I'm going to right click and choose Create Folder, and I'm going to call this Maze. And then inside Maze, I'm going to create a folder for my textures, and then another folder for my scripts, and that will probably do for the moment. Right, I am going to drag my maze tile set from my desktop into this textures folder. Now if I click on this tile set maze PNG, I can open it with my Sprite editor, and I am going to slice this up. So click slice and grid by cell size should be 256 by 256. Keep empty rects. This is kind of handy, this keep empty rects, because if you ever want to add to this tile set, add other tiles and things, then actually if you you can basically fill these empty rects later on. These are, they're basically empty at the moment, but you might want to fill them out with stuff. So I tend to keep this one ticked. Okay, so we do now have a very basic maze tile set, but it's quite amazing how much you can do with just a small little tile set like this. So make sure you click apply and close. Okay, I am going to create another folder here, and I'm going to call this scenes, and I'm going to create a brand new scene in this folder, create scene, and I'm just going to call this main scene. And then let's double click on that. Not bothered about that scene. So cool, we've got our own scene, just has a camera in, pretty standard stuff. Okay, now we want to draw our maze. So the easiest way to do that is if we right click in here, we can go to 2D Object Tilemap Rectangular. And now we have a tile map that we can draw to. But how do we draw to this tile map? Well, we need to create a palette. Again, let's create a folder for our palette, might as well. Keeping super organized at the moment. And then we can right click, create 2D tile palette, again, rectangular. And I'm going to call this maze, because this will be our maze palette. So if we come up to Window, 2D, we can click on Tile Palette here. Let's dock this here like so, and we have our maze palette already created in there. The other way you can do that is you can bring this tile palette panel up, and then you can actually create the palette directly in here like that. So that's another way of doing it. Okay, so we want to drag our tile set maze into here. So I'm going to drag and drop, and then I need to create a folder for my tiles. So if I click in here, probably put it under textures and create a new folder, and I'm just going to call this maze tiles, so I know what all these tiles are. And choose, and that will go away and create a whole lot of tiles. But the cool thing now is that we can click in here and we can start drawing stuff. But that looks terrible, and the reason why it looks terrible is we have not set the size of our tile set correctly. I'm going to set our pixels per unit to 256, and click apply here, and that's looking better already. So click on tile map, click on tile palette, and we can draw. Pretty cool, huh? Let's work our way from the middle outwards, and we'll draw one side of the maze, and then we'll essentially mirror it. I think that's probably the best way of doing it. So let's start with the center. So if I can work out where the center is, I think it's there. So draw that down like that. Draw that like that. Now you can draw your own maze, you don't have to copy my maze. But I have one that I'm kind of cheating and copying from. As you can see me looking to the left, trying to figure out how I did it. So yeah. So what I'm doing here is I'm just using the standard paint brush here in the tile palette. So if you're ever sort of, if it's not drawing for some reason, it's probably you haven't selected this, and then you've actually got to select the tile that you want to paint with. And actually you can choose multiple of these, so you can sort of click and drag, and then that becomes the thing that you're painting with. So that's pretty powerful. It's pretty cool. Okay, so the best way to do this, I think, is select those, and then, yeah, it's about there, I think. And then let's choose that and bolt that onto there like that. And then the cool thing about this, now I've created this object here, I can use that to draw with, which is kind of cool. So let me show you how you do that. So you can click on this marquee, select new brush, and you can actually select it from here. So that's kind of cool. And then I can do that. And then zoom this camera out a bit so we can see what we're doing a bit. So about there, probably going to be enough. And I don't want to draw with this anymore, so what do I want to draw with? I want to draw with that. So always keep like a square, a tile width for the monsters and stuff to walk by. So yes, that looks about right. Now what you can do, because it's a bit tricky to sort of draw in a line like this because you wander off to the side like that. So you can choose this one, which is, will fill a whole area like that, which is not what I want to do, but it's actually good for drawing lines as well. So that works quite nicely. I don't really know how long I want that yet, but there you go, that works. And then you've got an eraser here because like I don't want that bit on the end. Okay, now let me do my marquee select again. I just want to select the bottom of this, or maybe the top. Okay, I'll do the bottom. Try and work it out. So I think that wants to go there, and then I want to select the top of that, and that can go there like that. So that's looking pretty good. Let me do my marquee tool again and paint there. Now I think I started a little bit low. What I can do, move selection with active brush. So I think what I can do is select all of that. Will that work? Yeah, there you go. So I can move it up like that. I need to zoom my camera out a bit more. I actually think this bit here is too low, could move up one, so let me just do that. So again, just select these, move, there you go. So that's good. Yeah, I don't think it wants to go up even further. I think that's fine. Now I want to bring the wall out a bit here, so let's do that. So I want this one here. I want to draw there like that. And then do that. Draw that there like so. Erase that. I want to copy this down here, so let's do my little marquee select again. And I'm gonna put one down here and do another one here like that. I think these actually want to be further in. This wants to be in like that. Let's delete this. So I think I want essentially this about there, I think. I just want to delete these. Wants to go there like that, but of course that's wrong now, so we'll fix that. So that's a little bit tricky to fix with this tile set because we wipe out that, so we need another layer here to be able to fix that. So we'll do that in a second. Let's just finish with what we're doing. Reposition the camera a bit for the moment. Okay, so that's looking pretty good with a few gaps. And so we can fix the gaps by, well, first of all, let's add some flooring. So right click on the grid, 2D object, tile map, rectangular. Let's move this down to here, and I'm just going to call this floor because that's all it's going to be. If we make this 1 order in layer and then the floor 0, then it means the floor will be underneath the walls. So what we can do now is select tile palette. Make sure it says floor here. Sometimes you can get a little bit out of sync. And if it does, then you can actually choose it here, which layer you're painting to. So we want to choose this one, fill box, and we can draw in our floor like that. So immediately looking better now, huh? So that's our floor. But we do want some holes. We want some holes there and there and there, because what we're going to do is make this background black, and let's just do that now so that we can see what that will look like. So click on your camera, come down to environment, background type, solid color, and let's make it pitch black like that. Okay, so again, already looking a bit better. Actually, we want to black out this bit now, so it's actually good we changed that, makes it obvious. Other bits that we want to make black, tile palette, make sure we're painting on our floor, and let's erase that. So we do have some gaps. We have some holes here, 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 and here, which we will need another layer just to fill in this, because it's such a basic tile set that we need to employ some little tricks to fill those holes in. So let's do that now. So grid, right click, 2D object, tile map, rectangular, and I'm going to call this walls. I'm going to call this walls extra, and let's make sure that our walls extra is on top of our walls. So walls is 1, so if we do 2 here, then that makes sure that the walls will be on top, the walls extras will be on top of the walls. And let's see, right, let's try and fill this gap. So how do we do that then? So that is this, I think. There you go, that'll do. So we filled a little hole there. We've got this here. Well, that looks like that. That'll do. And then we have a hole here, which looks like that. That'll do. This one here again is this one. And that one there is a tricky one because we don't actually have that one. So we can flip this one because we want it there. So yeah, easiest thing is just to flip this one, or we could rotate the other one, but I think flipping might be better. So you can flip the current brush with this little gizmo here. Let's click it, And now you see, oh, we flipped it. So that's looking good. And then what we got here? We got that one, I think, fits there, doesn't it? No, it doesn't. It's top right. So it's this one flipped. So I want to do that. There you go. Cool. So we have half a level. Actually, no, we're missing this here. Let's just put. So that is, what is that? That is that one, I think. There you go. Nice. Command S to save. And we're still missing one. What is this? This is bottom right, which is that. There you go. Cool. I think we're good. Yeah, I think we're good. So let's save that. And we want to select the whole of that and mirror it. So let's see how we're going to do that. So we can do a marquee select. Let's select the walls. Do that, which is then painting with the whole of that. But of course we don't want to do that because that would be rubbish. But we can use this tool here, which will flip the whole thing, and then we are good, I think. There you go. Click. Done on that. We need to do our floors. So floor, let's just get rid of that. We can just paint our floor in because it's all the same tiles, so just click on this one, actually click on that, and we're painting in our floor because it's all the same tile, it's all that one there. So that is good. And then we do want to do our little extras. I could do them all singularly, but I'm lazy. So I am going to do marquee select, do that, release, flip, come back here and see if, yeah, there you go, that lines up. Click, click, and then we're just got some floor there that we need to delete. There you go. And there. Maybe it would have been better to marquee select it. Okay, I think that is looking pretty cool. So let's rest there. Now, to enable our enemies to find their way around this maze, we are going to use what's called a NavMesh. And the best way to understand a NavMesh is to just use it. So if you Google NavMesh Plus, this H8man NavMesh Plus GitHub repo should be in that listing somewhere. Or I will just drop a link in the notes. But if you scroll to the bottom here, it does tell you how to add this NavMesh Plus to a Unity project. Method 3 is actually the best method. So we want to copy that and we want to install it via the package manager. So if we come back to our Unity project, we go to Window and Package Manager, and click on this drop down next to the plus, and we want to install the package from a Git URL. Then we can paste in that Git URL and hit install. Once that is installed, we can close our package manager. Once Unity stops thinking about things. Very philosophical program, Unity. It likes to think about stuff a lot. Okay, so let's close that and just make sure we haven't got any red in the console after we click clear. And our NavMesh package is ready to be used. So what we want to do is, well, we can actually expand our packages and go to NavMesh Plus, click on the README, and we can just follow the instructions here. So using your project, create an empty object in the scene root, add navigation surface, and this NavMesh. Okay, let's do that. So right click, create empty. Let's make sure it's in the root. Let's just call this NavMesh. Let's reset it just to be on the safe side. And then we wanted to add navigation surface, I think it was. Yeah, that looks right. And then navigation collect sources 2D. Yes, that looks right too. And then it's saying NavMesh surface is not rotated respectively. So we want to click this rotate surface to XY to make that go away. And you'll see that it's rotated X to -90. It just seems that it needs that to do its thing. So that is a happy little NavMesh now. We can actually click bake and it won't do anything, but it's not complaining about anything either, so it's kind of trying to do something. Okay, so let's just save that. Now what we want to do is, if we expand our grid, now I'm going to add separate colliders to our grid. We could use the walls here, but I think it's a little bit cleaner and easier to add our own colliders in a separate tile map. So let's add 2D object, and let's add another tile map. Rectangular one, obviously. We're going to call this colliders because that's what it is. And this will be handy for baking the NavMesh and also for stopping our player from bumping into things. What we can do is we want to add to this, start typing collider, and we want tile map collider 2D on here. And we don't want to render this tile map. This is purely for collision. So I'm going to turn off the tile map renderer. Then I'm going to go to tile palette, and I'm going to use this block here because it is a wall. I can use any of these actually. Well, you actually want one that's filling the whole square, so the collider is correct. Because let me just do this. So if I just make sure on the collider surface, so if I just do that, you can see that it's put a green collider there. Whereas if I use that one, you can see that it puts a half collider in there. So it makes the collider the shape of the sprite. But for the moment, I'm going to just have the colliders as full-size tiles. And let's just try this out. So if I do that and come here can do bake. That's still not working because I need to add a navigation modifier tilemap. There you go. I could try again, and that is kind of working, but not really, because I want this to be override area. It's not walkable, it's not walkable. I'm drawing colliders. So let's see if that looks a little bit more sensible now. Kinda. Let's start drawing some more stuff and let's see what happens. So if I come to this tile palette and let's draw our walls in like this, like this, like this, and like this. Let's see what baking does now. So that's cool. So we've got a walkable area apart from there, but it should be able to send the enemy around there, but it can't get through there. So I think we're going to have to use the proper size colliders for this to get this to work. So these are right and these are right, but let's draw in the proper size colliders here. So we want that. Let's have a look. Let's see if we can get through there now. But let's draw this one in as well. That one. That one. That one like that. Okay, let's see how that's happier. And that is happier, but it's still a little bit constrained going through there. So let's draw that like that. And we can use that. But we don't want them that way around. We're going to have to flip this one. So let's do that. Flip it like that. And then, there you go. That's probably going to be happier. There, cool. So let's marquee select and copy some of this. And I'm wondering whether that should be like that one. Yeah, let's do that actually before we. So flip that, that one, and we want essentially that one but flipped. There you go, like that, and that one but flipped, like that. Bake. Yeah, that's looking pretty good. Okay, so let's marquee select. Paste that there. Let's do that one there, that one there. And I'm going to go away and do the rest of this. You can do this for your particular maze that you've created, or if you're trying to copy what I've done, well, I will stop the video here and restart when all the colliders are drawn in. Okay, once you've drawn in all your colliders, should look something like this. If you go to NavMesh now and click Bake, then you should see something like this. Now, what does this all mean? Well, essentially, what the NavMesh has done is it's figured out from all the colliders where the enemy can walk. So this blue area here is where the enemy can walk, and it's obviously avoiding anywhere that had a collider. And so what this NavMesh is great because you can create an AI script that will use something called a NavMesh Agent, and this NavMesh Agent will stick to this walkable area. So it won't walk through any of these walls or anything like that. It will stick to this blue area. And so to go from, say, here to here, it will go, should I go this way or should I go that way? And it will kind of figure that out itself. But it will not go through the wall. And therefore it looks like quite an intelligent AI, really. It's not really, but it looks like it's thinking about which way to go, and that's kind of pretty cool. Okay, now we have our NavMesh. Let's create an enemy that can utilize it. So, because our enemy is eventually going to be a blob, let's create a circle for our enemy. So 2D object, sprite, circle, because we'll turn that circle into a blob eventually. But just to keep things nice and simple, it will be a circle to start with. So let's start in the bottom left corner here. Let's call this enemy. And we're going to create a script. So click on our scripts folder, right click and choose create C# script, and I'm going to call this enemy AI. And let's double click on that. Now we need a reference to our player. So we're going to do serialize field transform underscore player. So our enemy knows where our player is. And on this enemy AI, we are going to have a NavMesh agent. So I am going to do private NavMesh agent, and this will actually pull in the Unity Engine AI namespace because that's where the NavMesh agent is. I'm just going to call this underscore agent, because what we can do is we can set this up on our start. So I can do underscore agent is equal to get component NavMesh agent. So of course this means that we need to add a NavMesh agent onto our game object, which we haven't done yet, but we will do. And then what we can do in update is we can say to our NavMesh agent, set the destination to our player position. Because we want to attack our player, we want to move towards our player. And so this is the magic source that will tell our NavMesh agent, go and find our player. And because you're telling the NavMesh agent to do it, it's going to use the NavMesh to do this. So it's going to traverse only on the NavMesh to get to our player. So I think we should stick our player in the top right corner so we can see that our enemy can get to our player all the way over there. So let's do 2D object, sprites. Let's make our player a triangle for the moment, and I'll increase the order in the layout just so I can see our player. And let's drag it into the top right corner. Let's call this player, like so. And then we want to drag our enemy AI script onto here, onto our enemy. And then we want to drag our player onto our player reference here. So now, of course, in our enemy AI script, this is all nicely set up. So our player variable will actually be this transform here. Okay, so we said we need to add to our enemy a NavMesh agent. So let's do that now. So if I just start typing NavMesh, then there you go. You can see our NavMesh agent here. And for the moment, we'll keep everything as default. Let's save. Let's hit play and see what happens. Now, as you can see, it is moving along here, but we can't see it. But that's pretty cool. It's going all the way over, so it is going over, but it disappeared here. And it was kind of rotating around. If we make sure the enemy's selected and hit play, it's probably going to be messing around with our rotation. Well, if we've got a blob sprite on there, we don't want the blob sprite to be rotating around, so that's not going to work for us either. So we need to do a couple more tweaks to our NavMesh agent to stop that from happening. So the first thing we need to do is we can do _agent dot update up axis equals false. So the up axis in a 2D game, well, if you know, we've got X and Y, up and down, but what it's talking about there really is up as in the Z axis, because actually the Unity NavMesh agent is a full kind of 3D agent, and so up, confusingly, up for the NavMesh agent is actually the Z axis. So it's saying don't mess around with our Z axis. So that should stop our sprite from disappearing, and then to stop our sprite from rotating around, we can do update rotation is equal to false. So we don't want our agent to be rotating around, so we're telling it not to do that. Let's try that again. Hit play. Now look at this. Our enemy's coming for us. It's going through the maze. and it's got us. How cool is that? Okay, it does feel a little unfair that the enemy can come and attack us, but we have no way of avoiding them. So let's fix that now. So if we come into scripts, right click and create C# script, and I'm just going to call this player, and let's double click that to open that up. Okay, what do we want in here? Well, probably be handy to be able to set our speed that we're running around at. So let's create a float, and we'll call this _speed, like that. Let's be specific and call it private. This private is actually optional. If you leave it out, then it's presumed that this particular variable here is private, but it's sometimes good to be explicit about these things. Right, what else do we want in here? Let's think. We want to take in input from our player so that we can move our player character around. So we can create here a private vector3, and we will call this _user input. Now we can use this in our update. As it handily says here, update is called once per frame, so this method here is called automatically for us. And what do we want to do? Well, we want to set our user input equal to, now it's a vector3, so let's create a new vector3, and we want the x to come from our input dot get axis raw, and this is horizontal, and input dot get axis raw vertical. So that's taking input from our user. So that is actually, I'll show you where this is set up in a second. We get these for free. Comes along with a default setting of Unity project. And yes, it's actually the AWSD keys and the arrow keys. We're using get axis raw because this is a little bit of a 2D arcadey game. So the get axis raw doesn't have any smoothing on it. You can actually just use get axis and that will work, but what you'll find is that the character will kind of speed up a little bit. So they'll press an input and it won't immediately go to full speed. It'll slowly get there. And that's because of it takes into account sensitivity. And I will show you where that is set up in a minute. But let's just get this working and then we can go through it. And then we want to do transform dot position is equal to transform dot position plus, and so we want to keep adding to our position this user input. Essentially we could do something naively like user input times speed, and that would look like it was working. So let's do that for the moment, because that's kind of super simple to understand. Right, we're taking our position, and every frame, and that's quite important, every frame. And if you think about it, the amount of frames that happen every second in a game can actually change depending on how powerful your computer is. So that's something to take into account. We're not taking that into account at the moment. So what we're doing is every frame we are taking the position and we're adding whatever our user input is. In fact, this vector 3, just to be specific, we can just put a comma 0 there. I don't actually have to. It'll actually understand that it's going to create a vector 3 of x, y, and 0 anyway if you leave it out. But just to be specific, right, we're setting the x of this vector to our current input, our y of this vector to our current input on the vertical, and z we're not touching. So, and then we're multiplying this. We're doing this first. Multiplications happen first. I mean, you can put brackets around this, but it's actually unnecessary because it does this first. So we'll times that by whatever we're putting in here. Maybe we should put in a default speed, because we won't see anything happen if speed is 0. So it's good to have a default speed. And that should look like it's working. So let's do that. Let's click on player. Let's drag our player script on there. It's set it to a speed of 1 as default. Let's click play. And actually, let's just disable our enemy for the moment, because we don't want to worry about an enemy chasing us around while we're testing out movement. So, ooh, wow, that is fast. That is fast. So let's take the speed down to 0.01. What does that look like? Super slow. Let's do. Oh, that's okay. Cool. Now, there's some obvious things wrong here. First of all, we're going through walls, so we're not taking into account any collisions. And also, one thing that's pretty subtle actually, and I'm using the AWSD keys to move this around, but I can use the arrow keys as well. So this is left arrow, down arrow, right arrow. Now, one thing that's not obvious is actually on the diagonal, we're going faster. It's subtle, but it's definitely there, right? You can see the diagonal is faster than going left, and you don't generally want that. And this is a mistake that I see happen a lot with people doing their character movement, is they forget about this one. So let's fix the diagonal issue first. So let's just put this in permanently, 0.09. And let's go into our player. And how do we fix the diagonal issue? Well, what's actually happening here is when someone presses the left arrow key, and actually let's just do this, we can debug this out so you can see this happening. So debug.log, and let's do X. In fact, we can just do user input, because yeah, that should work. So if I just do user input colon, and then what you can do in curly brackets, you can do user input, and it will just insert. This is quite handy, this way of doing strings in C#. If you put a dollar in front of a string, then you can kind of use these curly brackets to insert variables wherever you want in the string, and that's really nice. Otherwise you'd have to do like concatenation. That's another thing that works. You can concatenate variables on the end of strings, but it gets a bit messy if you then want to carry on the string afterwards. It wouldn't make much sense here, but you could do user input and I don't know, some exclamation marks or whatever, and it's just this, I just feel, is a little bit neater. Okay, so let's have a look and see what this looks like. So you can see it's all zeros at the moment, but if I hit left, you can see that immediately goes to -1 or X, and if I go right, either D or right arrow, it shows 1. If I do A and S or down and left simultaneously, you can see it's -1, -1, and so that's why it's going diagonally, because it's going left and down equal amounts, and so it ends up going diagonally across the screen. So hopefully you know, you have a basic understanding of vectors. They're not too complicated, but hopefully you can figure out what's working, how that's working from that very basic debug there. But what is not obvious is that on the diagonal, so if we're going left, we're just adding 1 to X, actually every frame at the moment, or actually multiplied by speed, so it's not quite that, but for example, say we didn't multiply by speed, or speed is 1, we'd be going 1 every frame to the left. If you go diagonal, then you're actually adding 1 to the left and 1 to the right, and Pythagoras comes in there actually, because you're going down 1 and you're going left 1, but which means that diagonally you'd actually be going the square root of 1 squared plus 1 squared, so essentially the square root of 2, which is, drum roll, well, I don't actually have to work it out. I can debug it out to our console to tell me. So what I can do is I can throw out user input dot magnitude. There you go. And a magnitude of a vector is essentially the distance, yeah? So you'll hopefully be able to see the issue, right? We've got 0 on the end here, so that's fine. We've got a magnitude of 1 going left and right, and up and down we've got a magnitude of 1. But look, if we go diagonally, 1.414 whatever, yeah? 1.414214, something like that, okay? And if I do the square root of 2, just to prove it to you, Pythagoras, square root of 2, 1.41421. There you go. So Pythagoras working there, and it's scuppering our speed on the diagonal. So there is a real easy fix for this, and you should just do it every time. Don't even have to think about it. So even if none of that means anything to you, don't even worry about it, right? All you need to do is do normalized, like that. And what I can do there is I'll just normalize that, normalized, and take the magnitude of that, and then you'll see how it fixes it. So again, left 1, down 1, diagonal also 1. Yay. And it may be pretty obvious to you that the speed on the diagonal is now good. Perfect. So we have good movement on the diagonal, which is what we want. And the only thing that is buggy now is that we are frame rate dependent, which is not good at all. We want to have a constant velocity in units per second, not units per frame, because our frame rate can change, but seconds are seconds, right? They're pretty solid. So how do we do that? Well, let's not think about it too much. We just have a little trick to fix this. We multiply it by time dot delta time. And that converts us to essentially a speed of units per second. And just very briefly, that is because delta time is the amount of time that each frame is taking. So by multiplying this here, if frames are very quick, then this is very small, and if frames are very slow, then it is large, and it evens everything out. So very basic explanation. Cool. So let's probably means that we have to up our speed a bit, because like I say, delta time is usually pretty small because the frames are quick. Oh yes, we can hardly even see that we're moving. Usually about 5, I think, is, there you go. Five is good. I'm going to stop that and do 5. Okay, so we're going through walls, and that's because we don't have a collider on our player. So of course we're going through walls because, okay, we have colliders here, so you can see we've got colliders here, so the player should be able to bump into these, but only if the player itself's got a collider, and you need a collider on both the player and on the level. Although it's not good enough to just add a collider, and let me just prove that to you. So if I do add component, collider, and let's keep it real simple. Circle collider will do me fine. I know I'm a triangle at the moment, but who cares? This isn't going to work, but I just thought I'd prove that it isn't. There you go. So we have a collider going through another collider, and that is pretty well known issue because in Unity you need a rigid body on at least one of the colliders for collision to happen. So it's generally you stick it on the moving thing, which is the player here. So rigid body 2D. There you go. Make sure you're adding a rigid body 2D and not a rigid body. So simulated has to be ticked. We do not want any gravity, and that should do the trick. Let's save. There you go. So we're banging up against that wall and we can't get past it, and we're banging up against that wall. But that does look rather rubbish, even though it's kind of working. I mean, if we zoom in, you can kind of see that we're going through this collider. I mean, let's see if I can select both. There you go. Look, we're going through the collider. Well, that's a bit weird. And that's because we're kind of fighting the physics in the way. The physics is doing its own thing, and we're kind of doing our own thing, and the two are clashing a little bit. So we actually need to go with the flow, and in this case go with the Unity 2D physics and utilize that for movement, and then everything will be a little bit happier than this horrendous. If that was a very thin wall, we could probably phase right through it, so not cool. Okay, so we will fix that next. Okay, what were we doing? Yes, we were going to fix our shoddy collisions, weren't we? Let's do that. So where's our script? There it is. Okay, let's double click that. Now you're probably wondering why I put user input here and we're using it here and here. So actually no reason at all for it to be a class variable. I could have just done a vector3 here, whatever, and done it that way. But it actually makes it easier for us to change our code to do our proper physics collisions. So we need to use fixed update. Now this is like the physics update, and so if we want to be in sync with our physics engine, we have to use this. So we've got that ready, but we do need a reference to our rigid body 2D. Rigid body 2D, and it doesn't look like we're going to be using start, so let's just change that to awake. Awake is the very first method that gets called, so obviously a good place to set up any references to components that we need on our game object, and we definitely need to talk to our rigid body component. So let's do move position, and then we can actually just take all this, paste it in there. Nice and easy update. So it's kind of exactly the same as this, but doing it via the rigid body 2D, so that it's friendly to the physics engine. Let's comment that out. Let's comment that out. Now you may wonder why I'm pulling in the user input here and not here. Well, update tends to be called more times than fixed update, and so it's a good place to take in user input. This has nothing to do with our physics engine, just pulling in what the user has pressed down on the keyboard, and we kind of want to do this super quickly, and so you'll find that if you did this in here, your inputs would feel sluggish, and it's just because this update is called more times than this. Okay, so let's see how that does. Oh, there you go. We are banging into that wall and we are not getting through it. So that is pretty cool. Oh, or not. That is pretty funny. Let's fix that. What's going on there? Well, that's an easy fix actually. We come down here to our rigid body 2D and we specify that we don't want to rotate on the Z. Let's try that again. Oh, nice, cool. That's pretty good, pretty good. I like it a lot. We can maybe just make sure that it's a little less sticky on the corners maybe. We can help that a little bit by creating let's create a folder, materials, let's create a 2D, make sure you choose 2D, physics material 2D, and I'm just going to call this slippy, and that's going to have a friction of 0, bounchiness of 0, and we will just drag and drop that on to our material there. And just to be safe, we'll drag it onto our rigid body 2D as well. Let's have a look. I feel that's kind of going around the corners a little better. Not much in it, but that is pretty cool. And actually, just to be clear, if we go back to player, assigning the material to the rigid body 2D is actually enough. Had to look that one up actually, but you can actually have multiple colliders on here with different physics materials, but if you've only got one, then adding the material to the rigid body 2D means that any colliders on that game object will inherit the material on the rigid body 2D. So it doesn't hurt having it on both, but I am going to just have it on the rigid body 2D, and this circle collider 2D can inherit that material from that rigid body 2D. So just clarification there. Okay, let's get our enemy wandering around our maze until they get too close to us, and then they'll come after us. So let's open up enemy AI. And we're going to add some more fields in the top here. So let's add in a float for our attack range. So when the player gets within this attack range, the enemy is going to come after us. Let's add a speed as well, because we have a speed for our player, but we don't have a speed for our enemy, so we should fix that. And now we need some waypoints. So the way this is going to work is the enemy is going to move between these waypoints until they get within attack range of the player. So this needs to be an array of waypoints. So we put a couple of square brackets on the end, and you'll see what that does in a minute. So let's use our speed first of all. So we can do _agent.speed is equal to speed. You're going to have to set that up in Start. So that's cool. Now, for the moment, let's comment this out. And let's think what we want to do. So we want to move between waypoints, and we're going to have multiple waypoints. So as soon as the enemy gets to one waypoint, it wants to start moving to the next waypoint. So we need to check how close we are, if we're close to a waypoint, and then we need to move to the next waypoint. So I'm going to do something simple like if underscore agent dot remaining distance is less than, and we can put something in. I don't tend to like to hard code values, but this is probably going to be fairly safe. 0.5f, and we need to track our current waypoint. So let's just keep a track, and let's have this public for the moment so we can see how this works. So we're going to call this current waypoint index. So essentially, our current waypoint index needs to be incremented if the agent has arrived at the current waypoint. But we've got to be a little bit careful because we can't just increment, because we'll go out the bounds of this array. So if we hit the very last waypoint, we need to go back to 0. And so there's a cool way of doing this, nice and easy. So we can do underscore current waypoint index plus 1. And let's put brackets around this just to be clear. And then we can do modulus waypoints dot length. And then we want to set our agent dot set destination to this waypoint. That's at this current waypoint index. So that's bracket underscore current waypoint index, and the waypoints are transform, so we just want to take the position of the transform like that. So let's see if this works, and then I will explain it. So we need to set up our waypoint. So let's create an empty game object, call it waypoints. Let's reset this, reset, and let's create our first waypoint. Let's just call this 0 because it's at the 0 index, or will be. And let's just double click. So it's up there, and we want to pull it down to here. And if you want to make it a little bit more visible, we can make it like a red dot. There you go, it's a little bit more visible now. So that's our first waypoint. Let's duplicate that and move our next waypoint up to here. Let's call this 1. Let's duplicate that. Let's move that over to there. Call that 2. And move that down to here. And that is 3. Now we actually need to assign that to our waypoints array here. Now it's quite tricky because we want to drag and drop all 4 of these into here, but if we start doing that, then that disappears. So there's a trick to this. Let's come down here, get that ready, and then we just click on this lock here. And then now we can click on that, and drag these onto waypoints, onto this bit here, and it will drop all 4. And you can see this is element 0, 0, 1, 2, 3. So that's worked. We can untick that now. All that lock does is it locks the inspector on whatever we've got selected. So we can select other things and it will still, the inspector will still remain on the original thing. So that's kind of cool. Let's also attack range, let's make that 0 so that it will just cycle around there. And in fact we haven't got the code for this, so actually it doesn't matter, but let's make this 5 and let's hit play and see what happens. And in fact, let's go down to here and have a look at our current waypoint index. So it's going there, incremented that. Should go to 4 and then go back to 0. So you can see that our enemy is cycling between all the waypoints. So let's just start again and explain what's happening. So our current waypoint index starts at 0. And so if we look at our code, okay, remaining distance is going to start off as 0 because we haven't really set destination initially. So it's going to come in here pretty immediately and it's going to increment the waypoint. Let's just see that if that is the case. I'm not telling lies. Yeah, I mean that current waypoint does get incremented immediately, which makes sense because yes, we haven't set our destination initially, so remaining distance is kind of undefined, but it's 0. So we'll come in here, it will increment the current waypoint index. So current waypoint index starts off at 0, we add 1, and we do modulus waypoints.length, and we've got 4. So it's going to, what this modulus does is it takes the, it's always the remainder that it returns. So it's going to be 1 divided by 4 is 0, remainder 1, right? So it's quite a clever way of cycling through between 0 and 3. It would just go 0, 1, 2, 3, 0, 1, 2, 3. Because if you think about it, once we get to waypoint index 3, which is this one here, because actually indexes start at 0, so this is 0, 1, 2, 3. Once it gets to current waypoint index 3, if this became 4, then we would get an error because this would drop out the end of the array and it would break things. But what it does is it goes 3 plus 1 is 4, but it does 4 modulus 4, which is 1, but of course it returns the remainder, which 1, remainder 0. So that becomes 0. So that's pretty cool little bit of math which is very, very handy. You'll actually see this quite a lot in programming. And then we assign the set destination to waypoints And like I say, this goes to 1 immediately. So waypoint 1 dot position. So it'll be this one here, the position of this one here. And so this starts marching all the way up to here, and it doesn't come back into this bit of code here until it gets within 0.5f of this waypoint, and then it will start it will come in here, increment this, and start marching towards the next waypoint. So that is pretty cool. Okay, so now all we need to do is add our code for when the player gets too close to the enemy. So let's do that. So player distance is equal to, and we can use our vector3 dot distance method, which takes two vector 3s and returns the distance between them. So we want the position of the player and the position of the enemy. This is on the enemy, so it's just transformed opposition. So that should return how far the player is away from us. And let's just log this out. Like so. And then we can say if player distance is less than our attack range, then, and we can use this thing that we just commented out here, we want to set our destination to our player position. And we actually want to return at this point because we're out of our patrolling mode and now we are in our chase down the player mode. So that's how this will work. So let's just run this to see what would be a fair distance for that attack range. So we're getting closer and closer here. We're patrolling up here. So it hasn't really dropped below 20, I don't think yet. Getting close. Maybe 10 would be good. I mean, it didn't quite, I mean, obviously at the moment it's set to 0, so we're never going to get that close. So let's have a look. Yeah, attack range is 0. Let's change this to 10 then, and I think that's probably good. So, just about out of range there, but now we are in range and it should be coming after us. Yes, it skipped that waypoint and now it is definitely got our scent and it's coming after us. So yes, and then obviously we're dead. Okay, let's bring in a couple of blob textures for our enemy. I'm going to drag this into our textures folder. So let's select both. You can select one and then shift and hold to select the next, like so. And then I'm going to choose 256 for our pixels per unit. Click apply. And just close our waypoints. Right, let's drag these. Right, so you select both, then drag and drop. And Unity is quite clever. If you drag two textures, it's going to presume that you're trying to create an animation using those two textures. So that's quite clever. And let's come into Maze and create a new folder called Animations. And we will put our animation in here, and I'm going to call this blob underscore walk, like that, and click save. And you can see that this has created a game object, and it has added an animator, and it created a controller for us as well. It did quite a lot. And if we double click this controller, actually created a state that it initially goes into that's connected to this animation, blob walk. If we double click that, then let's drag this and dock this animation panel here, and we can select blob, we can go to scene, let's get a bit zoomed in a bit, and let's just move that there for the moment, and order in layer, we need to get this above our layer for the level. And if I hit play, actually, yeah, one way we can do it is you just play the animation here. Now we've got this blob selected, or I can hit play here to actually see that it will play that default blob walk animation as soon as we hit play. Eventually, but this doesn't look very good. It looks like a twitchy thing, not a blob. So how do we fix that? Well, essentially this animation is just going too quickly. There's multiple ways of changing that. A pretty easy way is to click on these three dots here, and we can show sample rate, and we can set our sample rate to something like 1, which will slow things right down. Maybe too slow now. So let's change this to a sample rate of 2. There you go, that looks better. And we're just like a little blob blobbing along. Now we haven't assigned, let's just stop that. We haven't assigned this blob to our enemy. Let's zoom out a bit. So let's do that. We can, well, first of all, let's rename this to blob. And we can drag and drop that onto our enemy. And let's zero this and this so that the blob is right on our enemy game object. And then we don't really need our circle sprite renderer here anymore. Let's just remove that. But everything else we want to keep on there because it's got our AI script. Click on that, hit play. Now we have this cool blob moving around our maze. And he's coming for us. And he's got us. Now, I did say I was going to go into where this horizontal and vertical comes from. So if you go to Edit, Project Settings, you get this Project Settings panel come up. And on the left here, you want to click on Input Manager. And this is where horizontal and vertical come from. So if we expand horizontal, so this defines horizontal here. And the negative button for horizontal is the left arrow key. But it also has this Alt negative button, and that's A. By pressing on the left arrow key or the A key, then horizontal becomes -1 on the X. So that's how that works. And the difference between the get axis and the get axis raw is defined by the sensitivity. So this sensitivity here will mean that if you use get axis, then it will kind of ramp up depending on the value of this sensitivity. It won't go immediately from 0 to -1, say, when you press the left arrow key. It'll go over a certain amount of time. So because I'm using get access raw here, I'm ignoring that sensitivity completely, and I'm going from 0 to 1 immediately. So that's how that works. And of course we've got vertical in here, and vertical is defined here with the negative button being down, positive button being up arrow, and Alt negative button S, Alt positive button W. So that's how that works. Okay, let's just tidy up our names a bit. So I just want to call this controller blob. And then let's bring in a couple more textures. So we'll bring in our mouse 1 and 2 textures, and let's get our player moving around. So again, left click on mouse 1, shift click on mouse 2, drag it into our scene. We are going to have to select our animations folder, and I'm going to call this mouse, oh no, let's call it player underscore walk, and click save. Let's rename our controller that it just created to player. And let's have a look, where did it put this mouse? Here. Let's get it above our maze. And it's a bit on the big side, so let's reduce this down to 256 pixels per unit and hit apply. Let's zoom in, let's put it in the middle there so we can see it. It's still a bit big, but we'll address that in a minute. I'm just going to rename this to mouse. And let's select our animation panel. So we just have player walk at the moment, and my guess is that's going to be super fast. Let's have a look. Yeah, a little bit manic. I don't think it wants to be as slow as the blob. So let's change samples to 4 and hit enter. So it takes that. I think that's okay. That's about right, I think. So let's attach this to our player. And let's 0 these, 0, 0. And double click on our player so we can see what's going on. And I think, well, first of all, let's get rid of this sprite renderer. Don't want that triangle showing. And let's click on mouse and click on this scale thing here so that we can proportionally scale our mouse down a bit. Thinking about 0.6 is probably going to be fine. Let's have a look. I hit play. And of course, you can see the immediate problem is that it's playing that walking animation all the time. And that doesn't look right. For the blob, it's kind of okay because the blob is just a blob. But for a walking animation, you don't really want to see someone walking on the spot, so we need to fix that. Okay, so let's open up our player controller and we can see we have this walk. You can just drag this around. There's walk state. That's playing this player walk, and we kind of want an idle animation that's just standing in place. So what we can do is if we come into animations, click on our player walk, we can Command D to duplicate that. We can rename this to idle. Let's double click it. And let's get rid of that second walk frame because so we've got this kind of boom. I've got to select it to see it. So there you go. You see that second frame is that. You can see it's changing here. It's the sprite from mouse 1 to mouse 2. So we want to delete this second one. Oh. But make sure we're not select a player walk, we want player idle. And let's click on this one and delete it. But we need our player controller to make this our default animation. So let's drag the player idle animation into our player controller. Let's zoom out a bit. So we've got player walk, we've got player idle, and we want this to be our initial state. So set as layer default state. Right clicking on here, set as layer default state. There you go. So if I come back to scene and I hit play, the mouse should just stand there. And actually if I click on mouse and click on animator, you can see it's playing this player idle. We want the ability to switch between player walk when we start walking and then switching back to idle when we stop walking. So what we need to do is we need to add a parameter in here And there's loads of ways we can do this, but I'm just going to add a boolean, true or false, and call this walk. And right click, make transition there. And essentially, if I click on this transition, I can specify the condition that's going to move from here to here. And the condition is that the walk parameter here is true. Defaults to false, so it won't do that transition unless that somehow gets ticked. And then we can do a transition back, make transition, left click here, click on that transition, add a condition, and it will go back when walk becomes false. So it will go walk becomes true, bang over here, walk becomes false, bang back over to here. So that's how that works. So let's see if we can see this working in real life. The zoom on the game one here is not very nice, but we should just about be able to see what's going on. Alright, if I hit play, it's not doing anything. I hit walk, and hopefully you can just see that we are now walking. And then if I untick this walk, we go back to not walking. And you can see the transition's a little bit slow and sluggish. Let me just disable the enemy for the moment. Let's try that again. So click on walk, and you can see it doesn't quite immediately go over, and then if I untick walk, again it sort of pauses. And that's because if I click on this one, we have this sort of exit time and we have a transition duration here. So I'm going to untick this and I'm going to set that to 0, and then what this means is that that transition will happen immediately, and I'll do the same this way. Has exit time, transition 0, there you go. And so this will be an immediate snap between the two, a little bit like our get access and get access raw. We just want things snappy in an arcade game. So bang, there you go, bang, bang. Now it does look like there's still a pause here, and that's just because the first frame of the walk animation is still the kind of standing in place. So we can swap them around, which will make things look even snappier. Not 100% necessary, but if we click on walk, you can kind of see this is the standing in place one and this is the walking one. So what we can do is just move that over here for the moment, move that to here, move that back to there, and we just swap them around essentially. So let's go back here, hit play. Idle. And there you go, you see we're immediately switching between the two very quickly now. And I think that's quite cool for an arcade game. Right. Now, obviously we can't, be doing this while we're playing the game. We can't be walking around like this and then, oh, actually we're walking now, let's click this, and now we're walking, and now we stop, we go. We have to do it programmatically, right? So let's do that in our script. Okay, we have opened our player script, and let's just get rid of these comments, and we don't need to be told what update does, we know what that does. Okay, so we need a reference to the animator, because this is the animator here. You can see the panel here, it's called animator. This is the animator, and we want to get at this walk thing. So it kind of makes sense that walk is inside animator and we need a reference to it. So serialize field, animator, make sure it's not animation, it's animator, like that, underscore animator. And then we can come down here and we can do underscore animator dot set bool. Remember, this parameter here is a boolean, set bool, and it's called walk, and we want to walk every time our user input is kind of non-zero. So how do we figure out whether we've got user input? Well, we've kind of seen it before. We can use magnitude, because magnitude will be 0 if we're sat still, and it will be non-zero, greater than 0 if we're moving, if we've got a user input and we want to move. So this will be nice and snappy because we've done it in update. Now we can leave it like this, but if you want to do a slight little optimization, we can use something called square magnitude, because that does the same thing. I mean, square magnitude is going to be 0 if we're still, and it's going to be some value if we're not still. It's going to be a value greater than 0. But square magnitude is slightly more optimized, because magnitude you have to take a square root of a number. But with square magnitude, we're not having to take the square root. So it's just a little bit quicker, just a slight optimization, not a big deal. So let's come back here. So as you know, our animator is actually on our mouse, not on the player. So we want to drag our mouse game object onto there like that. And then the animator on that mouse game object is now assigned into our script. Let's see how that looks. So that's a good start. We're standing still. Now we're moving. And we're walking. It's a little bit hard to see actually. Let's zoom in on this one. And you can just about see that our legs are moving there. Got very short, very small feet. Okay, cool. So that's great, but we're kind of moonwalking backwards here, which is not ideal. Now the easy fix for that is inside our sprite renderer on our mouse, we've got a little flip here, which is pretty handy. So we can just flip our mouse round like that using that. So this is flip X. So let's do that in code. So of course we need to get at our sprite renderer, which is on our mouse actually. So we can cheat. Was it cheating? I don't know, but we can do something like this. It's equal to, of course it's not on, remember it's not on the player game object, it's on the mouse game object that's underneath here. So, but we do have animator that we've assigned, which is on the mouse. So we can actually do this. And we've got to our sprite renderer on our mouse. And then we just want to flip X, remember, and we want to set this to true when our underscore user input dot X, so left and right, is less than 0. So we're moving to the left. So we've seen, haven't we, before that it's -1 when we're going left. So that should do the trick. Let's have a look. There you go, going left and it's going, looking left, going right and it's going right. The only other improvement we can do for this is as soon as I release, it looks right again. And there's an easy fix for that, because you kind of want to remember, right? We're going left, we stop, we're still looking left really. It's a little bit weird to snap always to be looking right. So an easy fix for that is to just say if underscore user input dot x is equal to 0, return. So we don't run the code below if we're not moving. So this code here will only ever get run if we're actually moving, which is what we want really. There you go, perfect. Okay, we're doing pretty well. I'm actually going to change where the player starts, because the player kind of wants to start here. And then let's just move our graphic around so it doesn't look like we're walking into the wall here. Let's just see at the moment, because our circle is a little bit high on our body, we're kind of doing that. So we can just move our character up like that, and then I think that's better. So we're, yeah, I think that works well. And let's find that our head is above the wall there, because that's, yeah, that's totally fine. So what you'll find is Unity forgets any changes you make when you're during the play mode, when we're actually playing the game. Make any changes, it kind of forgets. So this Y is going to go back to 0. So I just want to copy that value, and when I press stop, as you can see, it's gone back to 0, and then I'll just paste it back in again. Just a quick easy way of doing that. And then let's just move that down to there, center it a bit, and that's a good starting point, I think, because the enemy is going to be in the corner coming for us. Now I reckon it's a cool time to add some gatherables, things that we're running around picking up in the maze, trying to get before the enemy gets to us and kills us. And if we can't get all the gatherables, then we've won the maze. So let's do that now. Let me add in some gatherable images. So I'm going to drag and drop this cool little piece of cheese here. I'm just going to call this gatherable. Actually, I might keep it gatherables. So then I'm going to drag this piece of cheese in here. Let's increase the ordering so that we're on top, like so. Maybe we want to be below our character though. So what's that, about 2? Yep. And it's a bit on the big side. So let's change our pixels per unit here to 256. Apply. And that's about right, actually. I like that. That's good. And if I put that cheese, say, here, and I'm just going to call this gatherable. like that. And then of course what we want is when we're playing the game, we're running around, and if we walk over the cheese, we pick it up. So we need a script called gatherable, C# script, gatherable, like that. Let's open that up. Okay, so let's get rid of all this code in here. And if we put a trigger on this gatherable game object that this script is attached to, then there's a bit of code we can put in here that will get called automatically. So this is on trigger enter 2D. Let's get this right. If we spell it wrongly, then it will not get called. So, and if we get the parameter wrong, it won't get called. So let's get it right. On trigger enter 2D. And let's just log something out to our console so we can see something happening. So collided with, and then we can just show the name of the game object that we just collided with. So this collider 2D is actually the collider on the other game object. So this will be on our cheese, and this collider 2D will actually be hopefully on our player. It's actually only our player that's got any colliders that are moving around the map, the maze. So that should do the trick. Now of course if I played this now, it wouldn't do anything because we haven't got, well, first of all we haven't dragged and dropped our script on there, so let's do that. But even now nothing would happen because we haven't got a trigger on here. So what do I mean by a trigger? Well, let me just show you. So if I do add component circle collider 2D, now this isn't a trigger. We have to tick this box here. I mean, if I hit play now, you see, we're just going to bump into our cheese because that collider is a collider. But colliders can be turned into triggers with just a tick of a box, and suddenly this is now a trigger. So now when I hit play, there you go. Collided with player. That's exactly what you wanted. So the player has walked into the trigger that's on our gatherable and fired off that little bit of code here. This gets called automatically as long as we have a trigger on our game object. Awesome. So let's save that. And what do we want to do when we've collided with our cheese? Well, we want the cheese to disappear. We want to make it look as if we've collected that cheese up. So that is really quite easy to do. We can just do game object because we're on our cheese. So game object is the cheese game object, the gatherable game object. So we can do game object set active false. Okay, let's check that out. There you go. We picked up our cheese. Nice. Now, of course, we want to have a score, and our score will be just how many pieces of cheese we've picked up. before we get killed by the enemy. So to let our user interface, our UI, know that we've picked up a gatherable, we need to add a bit more code to here actually. Ready for our UI, because I haven't actually written our UI yet, but let's get this code ready for that. So what we can do is we can come up here and we'll do a public static, and I'll explain what a static is in a second, action, and let's do tab there so that it's adding, action is part of the system namespace, so that got added automatically if you do tab. If it doesn't get added automatically, then just add it. You can add it at the end here, just say using system. But if you do tab, like I just did, it should get added automatically. And then I'm going to do, I'm going to call this action onGathered. And then what I can do down here is I can do onGathered, and you'd be forgiven for just doing .invoke and like that. And essentially what that does is that invokes the action, and so some other game object can listen for this particular action, and when it happens it can essentially run a method. But the trouble with just doing a .invoke, you will get an error at this point. Let me just show you. I hit play. And it just says null reference exception, object reference is not set. And that is because we haven't got any UI listening to this yet. And so it's trying to invoke something that's not there. So we can leave that in place because we will eventually set up some UI to listen in. But we shouldn't really allow an error to happen just because there's not some UI listening to this. So what we can do is we can just do a question mark there. And that question mark is basically it kind of checks to see if onGathered is null, and if it's null then it won't do the invoke. But if it's not null then it will do an invoke. So that's kind of like a real nice easy way of getting rid of that error. If I do it now, we won't get a null reference exception because it won't do the invoke. But it will do it when we've hooked things up. Now, I'm going to change that code in a minute, but make it a little bit better. But let's create a little bit of a UI just for our score. And it's just going to be a number in the top right corner. So let's do that now. So right click, go to UI, and I'm going to create a panel. And if I double click that panel, you can see that it's covering the whole of our camera. And I don't want that. So let's click on here. And if I hold down Shift, so it's also set pivot, and Option or Alt, also set position. And then if I do top right like that, it will anchor this panel to the top right here, and then I can set this width and this height to whatever I want. So 100 by 100 is 50 maybe. Just play around with these numbers a bit. 200, and we've got a panel in the top right corner where we can right click UI text, Text Mesh Pro. Let's add some text into this panel. Because this is the first time we've used Text Mesh Pro, it's going to come up with this little dialog here, and we just want to import the Text Mesh Pro essentials here, which will enable Text Mesh Pro to work. And all Text Mesh Pro is really is just text on our UI. It's somewhat powerful system for displaying text on our UI. And let's expand it to fill our whole panel. So again, Shift, Option or Alt, and let's click on this one here, which essentially gets it to stretch across the whole of our panel. And then I can come down here and center the text on both the horizontal and vertical, so it's in the middle of our panel. And I'm just going to type in 1, 2, 3 here, just to show that that's going to show some a score in the top right corner. Now that's all well and good, but there is a little bit of a problem here, in that if I change the resolution of my game, as you can see, that's gone pretty small. And then if I do it even more, to say 4K, I mean, it's unreadable. Our game, it looks fine, but the UI is not great. So you can do something to fix this, no problem. So if we come into, click on Canvas and Canvas Scaler, and we don't want constant pixel size because that's causing the problem. We want to scale with our screen size. So click on this, and what I tend to do is move this into the middle, so it kind of has a balance between scaling for the width and scaling for the height. So let's do that, 0.5, and 800 by 600, yeah, fine. So now if I change this resolution, you can see that our UI is not changing at all. So that kind of fixes that quite nicely. Okay, so this is now looking a little on the big side, so let's just adjust this. So I really kind of want it probably never going to be a huge number in here, so let's just do something like that. So it's tucked in the top corner like so, and I don't really like having a background on this panel, so I'm just going to untick that. And there you go. Maybe I can just make the text a little tiny bit smaller. So come down here, font size 32. Yeah, that looks pretty good. Maybe 30. There you go. Cool. So that's good, but how do we actually change this text? And let's name this text score. I'm just going to name this panel score as well, like that. So we need a script really to enable us to get at this text so we can change it. So I am going to create an empty game object called UI. Let's reset the position. And I'm going to add a script. This is a simple game, so I can call a script UI and it will handle all the UI in our game, but often if you have a very complex UI, you might want to split this functionality up into lots of little UI scripts, but this is a pretty basic game, so I drag that onto there like so. Let's open that UI script. Let's get rid of all this. let's do a serialized field, private text mesh pro UGUI. That's the one we want. If I hit tab, it should add the using TM Pro. And I'm going to call this text score, like so. And then on awake, just to show that this is working, I just want to set the text to 0, like so. Now let's come back here, and we need to hook this up. Let's click on UI, and you can see we've got this field here. All we need to do is drag and drop our text onto there, and we've hooked that up now. And if I hit play, let me just save. If I hit play, we should see this go to 0, because on awake we are running that bit of code that does that, and there you go. But of course we want to increment that when we pick up some cheese. Now we shouldn't really be doing anything like incrementing and tracking scores and things in our UI. Our UI should be fairly dumb. It should not be tracking data, at least not fundamental bits of data. So where should we put, how much cheese we've gathered? Well, we can actually use gatherable, and I did say that I'd explain statics to you, and I didn't. So let me fix that now. So let's create another static. So I'm going to call this private static int gathered. So let's do a little comment here, which is all the gatherables that have been gathered so far. Now this may look a little weird because this is on a game object, and of course we could have many game objects, many pieces of cheese that have the gatherable script on them. So initially, let me just create another piece of cheese then. So if I duplicate this and I move this over to here, say, then we've got two pieces of cheese, and they've both got this gatherable script on. And so it may seem weird that we've got this gathered on here. Isn't that held on every game object? And that's going to be very confusing because, that piece of cheese has got gathered of 3 and that piece of cheese has got a gathered of 4. It doesn't make any sense, right? Well, actually, that is what a static is all about. A static means that it's not the instance of this class that has this value on it. It's the class itself. And we just have the one class, gatherable. We may have multiple instances of gatherable. We might have multiple cheeses that have gatherable on it. But the class itself only exists once. And so we can say, oh, well, on the class itself, on that one instance of the class, well, it's not even good to call it an instance because it's not. That just on the class itself, we are going to hold a variable called gathered. And so there is only one version of this gathered, and so we can use that to track how many cheeses that we've gathered. And we can do that very easily. We can come down here and we can do gathered ++ done. And so every time we pick up a piece of cheese, this one version, this one variable is going to be incremented. And the only trouble is that we've made this private. It's always good to try and keep as much stuff private as possible, because maybe only gatherable should really update this gathered, but the UI needs to see how much has been gathered. But we can send it, actually. We can send it as part of this action. So we can put these funny little brackets here with an int on there. And now, onGathered expects to have an int sent along with it. So we can send gathered along when we invoke this action. So this action expects an int sent along when it's invoked, and so that's exactly what we can do. So how do we kind of listen to this action and know when we've invoked it? Let's do that next. We can do onEnable. So onEnable is something that's called on a game object when it's enabled. And most game objects are kind of enabled anyway, generally, unless you specifically have gone into the editor and disabled it. So this does get called on the UI because that UI game object's never going to be not enabled. Not by us anyway, generally. So on an enable is a good time to set up any actions that we're listening to. So we can do something like gatherable.onGathered, and we add what we call a listener to this onGathered action. And a listener is just a method, really. It's just a method that gets called when this action's invoked. So we can handle gathered, and then I can do here void handle gathered. Now we've sent along an integer, if you remember rightly, so this will get how much has been gathered automatically sent to it. So handle gathered gets this filled in automatically, and we can just do textscore.text is equal to gathered, and that's an int, so we need to convert it to a string so we can assign it to our text box like so. And the only other thing we want to do, just to be on the safe side, is on disable we should always take off our listeners. So remove our listener that we've added on enable, and the way we do that is we do a minus equals like that. So let's see how that works. Okay, score is 0. Now it's 1. Now it's 2. Awesome. Let's just go through exactly what we did. We set up this action here that we're going to invoke whenever we pick up a cheese. When we invoke it, we're going to send over how much has been gathered so far, and we're tracking that inside gatherable, but as a static int. So there's only one version of it, so to speak. There's only one of these integers flying around. And so we send that along because we've just incremented it. So gathered that's an increment. So that's exactly the same as writing gathered equals gathered plus 1. It's exactly the same as that. It's just a little bit neater to do it like that. And so if it's 0, now after this line it's 1. So we've called onGathered, we've invoked onGathered and sent it 1. What's listening out for this? Well, the UI. The UI is listening out for it. It's saying, oh, I want to know when something's been gathered. And the beauty of this is that it means that the UI and gatherable are very separated from each other. Gatherable has no idea about UI. And so it shouldn't, right? It's, gatherable should be doing its thing, and it should not care about the UI code. We should be able to delete this code, rewrite it, because what you'll find in games is that the UI, all the user interface elements tend to get changed a lot. When you gather something, at the moment it's simple, we're just incrementing a score. But who knows, we might want to set off some fireworks, we might want to set off a sound, we might want to, do a particle effect, whatever. And so the UI always tends to get more complicated. And by separating this, by having this gatherable just fire off an action that any other part of our code can listen to, means that gatherable doesn't need to know about fireworks and sounds, and doesn't need to know about the UI, doesn't need to know there's a score on the screen or anything. It doesn't care about any of that. It's just saying, oh, I'm a piece of cheese, I've been picked up. Anybody who wants to know about it, this is the amount of cheese that's been gathered so far, and this piece of cheese has just been picked up. That's what it's saying. And everybody else, at the moment, it's just this piece of UI that cares. But just, if we did like a sound manager, the sound manager could listen, could do exactly this, could onGathered and then play some gathered sound. And then that would auto magically kind of work. So it's really nice. This is actually called an observer pattern, and an observer design pattern. And it's pretty powerful, and definitely should be the way that you kind of write your UIs if you want to have a nicely separated UI from the rest of your game. Because actually, when your UI gets more and more complicated, sometimes it's actually handy to have the whole of your UI within a scene on its own. And there's just one scene that holds the whole of your UI. And so having this sort of loose coupling between your game and the UI comes extremely handy at that point, because the UI is in its own scene. It can't really very easily get at anything else. And so this observer pattern means that it can just observe things like onGathered and update itself based on listening to these actions being fired. Okay, the next thing we need to do is create a game over screen. So let's go to UI and panel. Gonna name this panel game over. And we want some text on here. So UI Text Mesh Pro, and we can, let's see, say game over. That's center and center. Let's call this text game over. Let's make this panel. So let's click on this box here, anchor presets, hold down Shift and Option or Alt, and just center this. And then we can come back to width, and I'll just do 200 and 200. That might be enough. Let's see. Okay, so let's add a button. So let's right click our game over panel, come to UI and button, Text Mesh Pro. Let's call this, well, let's put the text on the button to say restart, simple as that. And let's anchor this button to the bottom of the panel. So Shift and Option again, and click this button here. Let's make this button a little bit higher, so something like that. Let's get rid of the image on here, so I'll just disable it. Let's actually change this text to be capital, like that. And let's stretch this text to the width of our panel, so we can just increase the width until we get something like that. I think that's fine. Now, if you want to see sort of better gizmos in the UI for resizing things, instead of, I mean, I've just been doing this, which is nice and easy, but if you want to see a little bit more what's going on, you can actually, it's this gizmo here, which is T, and this kind of shows you the size of the UI elements a little bit clearer, and these little arrows here which show, you know, if it's set to stretch with the component or not. And you know, when they're down here like this, it shows that it's anchored to the bottom of our panel. So that can be very handy, because you know, we can just resize the panel and you get the elements to move with that. It's quite handy for laying things out. Let's just do it like that, and I think that should do. Let's rename this button Restart, and let's add to our UI public void restart game. And what we can do to restart the game, the very easiest way, because it's quite hard to reset everything, but the very easiest way to reset everything is just to reload the scene. So that's a quick, easy way of doing this. So we can do scene manager dot load scene, and because we've only got one scene, we can actually just use a 0 in here, but we do need to make sure that in build settings we just have one scene listed in there. So let's just do that now. So if I go to File and Build Settings, and that's the wrong scene, that's not our scene, so let's select that and just hit delete, and then add open scenes, which there's only one scene, and it's our main scene. So this is when it talks about load scene 0, this is the 0 indexed scene in here, and so that will load that particular scene, and we just need to hook up that button. So if I click on the button, when we click, it's going to run whatever's in here, and what we can do click this plus, then we can drag this into here, click on here and choose UI, restart game. Save that, and when we press that button it will reload the scene. Let's just see that happening. So let's just say move around and pick up some things, and then if I hit the restart it will actually reload everything. Now there's an interesting side effect here, which that this did not kind of reset. So this number is seems to reset there because we're setting the text manually to 0, but actually when we then pick up some cheese, what's happening is this gathered here is not getting reset. So there's an easy fix for that. And the reason why it's not getting reset on loading the scene is because loading the scene is not having an effect on this class. This class's variables, these static variables, are not affected by scene loads, and that can actually be very powerful. It's very handy to keep state across multiple scenes, loading and unloading. You can keep state in a static variable and it won't get lost. So it can be very powerful, but in this particular case it's a bit of a pain because it's keeping state, i.e. keeping the value of that number and not resetting it. But it's actually a very easy fix because we can just, on the awake of these game objects, remember there could be multiple, so this actually will reset gathered multiple times, but we don't care about that too much. Because it only happens at the start of the game, and gathered, doesn't matter how many times we set gathered to 0, will live, because once the game started it will get incremented and it's all good. Okay, it's kind of a bit rubbish to have our game over screen showing before we've even started, so let's fix that now. I'm going to add field here. We're going to call this game over panel. So this will be a reference to our game over panel because we want to basically hide it. Initially anyway, on awake, so set active false. While we're here, we might as well also set up a reference to our game over text, because we're probably going to want to change this depending on whether we die from the enemy or whether we win the game. So at the moment it's saying game over here, but we're going to want to change this to whatever, winner winner chicken dinner, or you win or whatever, if we win the game. Now, how do we win the game? Well, we win the game by collecting all the gatherables. Now, we know when we've picked up a gatherable because we've subscribed to the onGathered action here, and that calls handle gathered, and we'll get the number of gatherables gathered, but we don't actually know what is the maximum number of gatherables on our level. I've got 2 cheeses at the moment, but I'm probably going to throw a few more down all over the level. And of course I could keep that as a field on here that it checks against, but let's be a little bit more clever about this so I don't have to worry too much about it once it's set up. So what I can do in here is I'll update the score, and then I'm going to work out, is this the final gatherable? So how do I work that out? total gatherables left. So essentially, when that reaches 0, I want to show the game over screen and change the text to "you win." But how do I figure out how many gatherables are left? Well, actually, we've got this quite handy thing called find objects by type. I can do gatherable here. And we actually want this second option, which takes whether I want to just find the active or inactive objects. So this is find objects inactive. Well, I want to exclude those because I'll have made all the cheeses inactive when I've won the game. So that's that, and then I've got to do this sort mode. I honestly don't care about the sorting of these gatherables, and then that passes me back an array of all the gatherables that are active, and I just need to find the length of that array. And let me just move that up here and stretch that across so you can see the whole of that code. And so let me just go over that again. So it's finding objects by type, and it's just essentially the game objects that have the gatherable script on. At a very basic level, that's what it's finding. But I'm excluding any inactive game objects. And as you saw, when we pick up a cheese, we're basically setting that cheese to inactive. And so once we picked up the very last cheese, there actually will be only inactive gatherables in our scene. And so if we exclude those inactive ones, we'll essentially have 0 coming back from here. Let me debug this out so we can prove that this is working. So gatherables left and total gatherables left. Spell that right. There you go. And then if total gatherables left is equal to 0, then what do we want to do? We want to set our text game over to "you win," and we want to show the game over panel. That's true. Okay, let's see if that works. First we need to hook these up. So game over panel, text game over, text game over. Save that. There, and gatherables left 1. There is 1 left. Yay! Now maybe we shouldn't be able to wander around after we've won. So let's fix that, but that's working nicely actually. So let's just get a reference to our player in here. And when we win, there we go, I'll set it to false. Because we're going to load the scene when we restart the game, and that'll just reset everything. So player, there we go. There you go. Cool. Got a win state. And a restart. And we just win because we don't have an enemy to stop us, and we haven't really made it very difficult yet. Okay, let's put the enemy back in the game. So of course the idea now is that the enemy gets us and should kill us, yeah, and it's game over and we definitely haven't won. So let's sort that out now. Okay, let's open up our enemy AI script by double clicking on it. And we're getting attacked by the enemy when we're in attack range. And here we really want to say if underscore agent dot remaining distance is less than 0.5f, then we're going to accept the fact that the enemy has caught up with us and killed us. So you want to do something here. What does that something look like? Well, let's again invoke an action. Let's create a public static action. Press tab to auto add using system, and then we're going to call this action on player attacked. And so we just want to invoke this when we're attacked. Invoke. And let's put that question mark in just in case we haven't hooked it up for some reason. So that should work nicely. And then we just want to handle that in here. So we can do something like enemy AI dot on player attacked plus equal handle player attacked. Let's take that, copy it, but remember to remove the listener method, and then we want to handle player attacked, set up our method that gets called. And what do we want to do? We want to do fairly similar to this. We want to show the game over panel and set the player inactive. Like so. We could change this text explicitly and just say you lose, but it actually says game over by default, so we don't have to do that. Let's see how that looks. Game over. And try and move around. We can't. Click restart. Oh, just about won before the enemy got me. definitely one there. Not quite. There you go. So I think that works quite nicely. Okay, so let's do some final tidying up. So let's just get rid of that game over panel because it's sort of in the way. So that's the one that we set active or inactive. So we can safely just set that inactive. That'll still work fine. Gatherables. Now, I don't know for certain, but I guess we may add some more functionality to these gatherables. And if I clone a load of them, or if I duplicate a whole load of them up and place them all around the maze, I kind of want to be able to change them once and it will change all of them. And there's something called a prefab which will enable that to happen. So if I actually create a folder called prefabs within our maze folder, let's just delete this gatherable for the moment, and then if I drag this gatherable into our project window and place it anywhere inside the project window, it will create a prefab. I just happen to be throwing it in this prefabs folder, but it doesn't have to be in any particular folder. Just the fact that you've dragged it from the hierarchy into the project window is enough to create a prefab. And it just says here gatherable prefab asset, and let me explain what that does. So what you can do is you can double click a prefab and edit it, just the prefab itself. And prefabs are handy because you can open, say, another scene, create another scene, and then you've got this gatherable that you can just drag and drop into another scene. So they're very handy for almost the idea of portability. What I'm actually going to do is I'm going to create an empty object, game object, and call it gatherables, just because I like to keep things neat. And let's drag that down into there. Let's do that, and we can duplicate it, and this is still a prefab and shouldn't be overriding anything. And if I click select here, it'll actually select the prefab, the original prefab. So let me just show you how prefabs work. So say for instance I decide that this circle collider is say too small. I want to make it a bit bigger. Well, normally I'd have to, if this weren't prefabs, I would have to come into here, make this one bigger, then come into here, make this one bigger, and I can still do that, right? I can still come in here and I can come to our circle collider and I can increase the radius and say, oh, I want that to be about 1, say, and then come into here, and you see that hasn't changed, but I could make that 1 as well. So I can treat them individually still, no problem. But what it's now saying is, if I click on the overrides, it's saying I'm overriding the circle collider on this prefab. If I revert, then it goes back to what it is on the original prefab. So it's a radius of 0.55 whatever right here. And same with this, I could go here and revert, but just to show you what happens if I change the original prefab. Let's say I want to change this to a radius of 0.7. and this is also the handy thing for, you know, if you want to double click and see what that looks like, you can do it here, and you know, 0.7. So it's good to be able to do it kind of visually like that. And it's got an asterisk there, but if I click away, it automatically kind of saves it. And if I come back here, this one still will have a radius of 1 because we overrode the prefab setting. But this one here will actually get the new radius of 0.7 because we haven't overridden anything with this one. See, there are no overrides there. And you can come back here and kind of revert the override, clear the override in a way. And if I revert it, it'll actually go back to 0.7. So now you're probably starting to get an inkling of how powerful and handy prefabs are. And the more you use them, the more you find that they're pretty amazing. So let's place these all around the place. I'm just doing Command D here just to I'm going to kind of do them fairly shoddily. Should probably place them a little bit neater than this, but I'll leave that up to you. And of course, I'm now thinking that these you know, 0.7 as a trigger. Yeah, maybe it's too big, so but I don't have to worry because I don't think none of these are overridden, of course, because I've just placed them down. So I can go back to the prefab and change it back to close to what it was, 0.6, 0.5 something, wasn't it? But let's make it 0.6, it's fine. And all these are now 0.6. So I only had to change it in one place and it changed the whole lot of them. So super handy. Let's put one down here. Duplicate that actually and drag it across to there. And duplicate that and drag that into that corner. Drag that into there. So hiding a bit there, doesn't matter. And put one in each corner as well. That's probably enough. These probably need coming down a bit, just make it a bit neater. Cool. I think that'll do. Okay, let's do some more tweaking. Because it seems to me like the slime is a little bit sluggish, a little bit all over the place. And that's pretty easy to fix. He looks a little bit drunk at the moment. Like he's staggering around a bit, which might be quite funny to have a drunken slime wandering around the dungeon. But let's try and fix that. So just to keep the player out of the equation, I'll set the attack range to 0, so he's just going to wander around. Let's get this playing, And let's tweak a few parameters to see if we can stop that drunken behavior. So that mostly just comes from these values here actually. So, and it's super obvious if I whack up the speed. So if I whack up the speed, it's like he's overshooting and he's, oh dear. He really is like a bad car driver. He's just like, so this is because the angular speed is so low, and so it's kind of really not making him very efficient. So if I whack this right up, then it's still not improving because I don't think we've got enough acceleration. So let's whack that up. There you go. Now he's burning around like he's, well, drunk too much sugary drinks, let's put it that way. Okay, so that's definitely an improvement. Pretty sure the angular speed is a problem if that's too low as well. So if, yeah, let me just double check that that is the case. If I lower it down, it doesn't seem to have as much effect. I guess because we're not rotating or anything, so it probably doesn't have any effect at all really. So it's really this acceleration that was the issue, so that's good to know. Well, that speed is crazy. So I think if we brought it down to a more sensible speed of, say, what, 8 or 7, then. So based on that, I'm still going to whack the angular speed up because I don't think it makes too much of a difference. And I'm going to whack our acceleration up to 500. And let's just play around with the speed a bit. So we do kind of want, let's set the attack range to 10. I need to restart, so let me just change that back to 10. So it's coming after us, and see, probably we want the slime to be just that little bit faster than us, so that we really do have to kind of not have it. Do kind of quite like the speed of the player. So I think the enemy speed can just be a little bit faster then. So let's make that 6. Let's try that. Oh, he's really going to catch me if I'm not careful. Oh yes, yes. Okay, I think that's probably a good enough challenge. So let's keep that like that. But of course, let's add another enemy. And then that's going to make things really interesting. And finally, yes, let's add ourselves another enemy. So let's duplicate this. Let's drag our friend all the way over to the right side of the dungeon. Let's bring in a couple more blob textures. So I'm going to drag blob 3 and 4 into here like so. Let's select them both and drag them in here just so that we get our animation and controller easily created. Let's just come in here. So this is going to be blob so. So that created that controller here, which is actually, let's rename this to purple. And let's just double click on that. So of course this controller, all it does is run this animation. So we don't really have to do anything fancy here. We just need to swap out this controller on this enemy. So this one's using blob at the moment, but of course we want to use blob purple. Let's remember also to change our pixels per unit to 256. Click apply, and let's hit play and see if that works. It does, but that blob looks a little bit manic because we just need to change this to 2, don't we? Samples, slow it right down. Don't need this anymore, so let's just delete that because that was just used to create the controller easily. And let's just rename this enemy underscore purple. And it doesn't look purple at the moment. I mean, it changes when it plays the animation, but it'd be kind of handy just to make it look right initially. So that's this. Let's just drag that one on. Where are we? There. There you go. So we're now looking purple there. Save that. Let's see. I'm thinking this is going to be pretty hard now, actually. Yeah, I got 2 enemies. Oh, yeah, this is tricky. This is good, you know, it should be tricky. So I scored 5 there. 1, 2, 3, 4, 5. Yeah, obviously. There's probably one hiding there, is there? Oh. Yeah. Definitely not good in my own game. Look at this. This is good. Oh, no. So always good to play test to make sure that it's pretty tricky, but maybe doable. It's probably not the greatest move. 7, 8. Oh no, oh no, no. 9, 10, 11, 12. Yeah, okay, cool. I think we've got a game there.